see now how to perform a one sample t-test. So you open your data, you browse the file, okay, you select the data frame and you open them. Now you go to the t-test, t-test square here, selection, and you choose one sample t-test. Okay, now the variable that I want to analyze is the reaction time, so I put it here in the variable. In this case, the software, I need to specify the software to which value I want to compare my distribution, because as you remember, the one sample t-test is a test of a distribution of the data against one value, which could be whatever value you can find in literature. So for instance, in this case, I want to see if the reaction time in my task, if the average reaction time in my task is different than an average value that I've seen in the literature. And let's say that the value that I've seen in literature is that in this case I have a reaction time of 500 milliseconds. I specify it here in test value, and as you could see, as long as I click on enter here, it pops out the result of my t-test. So first of all, you can see that the p-value is less than 0.005, so the reaction time that I recorded is actually statistically significantly higher than the value that I've input here, which is the value that I usually find in literature. So I can say that in my case, in my task, the task produced a statistically significant lower reaction time than the one that we find in literature. We can calculate it. We can calculate with this result also the effect size, which is the Cohen's d. The Cohen's d is very low, so it's below 0 by -10, so it can be considered significant. It is -0 because the direction of the test is reaction time that I have minus 500. And as you can see, the t-value is negatives because it's negative 319.1. So this means that the average of my value and the average of the value in literature differ by 319 milliseconds, with the average of my data being lower than the average of the value that I found in the literature. I can also plot. I can also make some plot in this case, where, for instance, I can make what is called. I can make bar plots. In this case, you see here it's just one column because it's one data set. Okay, and I can make what is called rain cloud plot, which is very nice. In this case, what you see is, first of all, at the center, the box plot of your data. On the right here, you can see the distribution of your data. So as you can see, it peaks around 300. And on the left side here, you can see a very nice plot of each data point. So this is the distribution or the plot of each separate data point of my data set. I think that this is a very nice plot because it displays all the data all together, so you have a clear view of how your data look like. Now, as we discussed in class, there are two direction, you can, what we did was a t-test where we tested the differences between our reaction time and the reaction time that they found in literature. And I just test the hypothesis that one average, so the average of my data is different than the average of these, what I found in literature, so this number here. As we saw in class, you can also give the test a direction. So when you give the test a direction, you check whether the data are on over a certain limit on one side or the other side of the distribution. So you can check what is the t-test against the hypothesis that your data set is higher than the test value. So if you look at that, it will return you a p-value of 1. This is because the average reaction time that you have in your data, it is not true that is higher than the test value, that is 500. So the test returns you a very, very low probability to find a high value in your data set. Since your data set has an average that is lower than the test value here, when you click on less than test value, here will be, it will gives you a very highly significant result. So if I click on it, as you can see, yes, it will give you a very high significant p-value. So the p-value is 0.001, which is a lot lower than the threshold of 0.05. It means that in this case, the alternative hypothesis is that your reaction time is lower than the test value, which is 500. So that's why you just check whether your distribution is on just on one side of the tail. So basically it's very far from the value of 500. What we have also seen in class is that you can check the normality of the data, and there are the normality plots, and as you can see here, before the normality plots, you can see the Shapiro-Wilk test. The W is very is very close to 1, which means that it's the data looks like that they are very, very normal. The p-value is not significant, so you can basically assume that your data are normally distributed. What you can also do is to click on descriptives and check the QQ plot, which is the plot that tells you how much data are normal, so visually. So here you can see the data are very well aligned to the line here, to the, let's say, inclined line, like the slope of this line. So since they are aligned, and since the Shapiro-Wilk test gives you a W that is close to 0 with a p-value of 0.5, you can assume that your data are normally distributed.